We're going to learn what rational indices are, and we're going to do conversions and learn how they work. And firstly, you can see the word rational there in the title. It's when you have a base that's raised to an index that's a rational number. So what goes there, the index is a rational number. Now, rational number is basically when we have x over y where both x and y are integers. So that means, as you know, integers are positive and negative whole numbers, including 0 as well. So you have to have integer over integer to be a rational number. So that's what's going to appear there when we write it in power form. Now perhaps you can see a result here. It's claimed that the cube root of 8 equals 8 to the power 1/3. Let's have a look at that. Now on the left we've got 2 times 2 times 2 equals 8. Another way of writing 2 is the cube root of 8, because 2 by 2 by 2 is 8. And if you have 3 of those together, you're cubing it. The result is 8. We can get 8 as well by cubing something else. If you like, you can use index law number 1. But either way, you cube 8 to the power 1/3, you get 8. You cube the cube root of 8 and you get 8. Therefore, the cube root of 8 equals 8 to the 3rd. So that demonstrates the result of the first index law for rational indices. A base A to 1 on n equals the nth root of A. So n is an integer, and that is called the nth root of A. Okay, that's the nth root of A. A you can see contained in there. So it all starts with square root, which you'd be very familiar with. Square root of x would look like that. Now, you could put a 2 there. No one ever does that, but it would be right. So square root equals the second root, I suppose. But you might have even seen beyond that the cube root, the 4th root, perhaps, possibly. But you can keep taking these up to higher values. And this is where it links to this rational index law. So a to the power 1 on n is the nth root of a. The other result pretty much subsumes this one. So the second result is the king of the results for this video, at least. A to the m over n, there's your rational index, equals the nth root of a to the power m. Notice how the integer on the top, when we write it in surd form, sits beside the base there, and the integer on the bottom, when we convert it into surd form, is the nth root, which is related to that n there. So the two forms, that's in power form there, that's power form with a rational index, and that's surd form, which you're familiar with from our previous work. Okay, so that's converting the same information to surd form. Let's look at some examples. So let's say we had to write square root of 17 with a rational index. So it's going to be an index form with a rational index. So remember that you could, because square root is the inverse operation of squared, you could write a 2 there, not that anybody does that, and that would follow the rule, the 1 on n rule that we just saw. and that'd be 17 to the half. So the square root of anything is that base to the power 1/2. So that's an example of that one there. Another similar example, the cube root of 3 would be written as 3 to the 1/3. Here's another one. We have to do the same thing with the square root of 7 times w to the 4th. Notice how the entire expression 7w to the 4th is all under the radical sign. That's important. And basically, if we need to write that as a rational index, we can split that up as square root of 7 and the square root of w to the power 4. We could do it that way. Now that was just an example of things we've seen before like this that you should be familiar with by now because that's from our previous work. So that's just using that property there, so it's splitting them up. So the square root of 7 is 7 to the half times w to the 4 over 2, and that second part there is an example of this. So we've got, is that finished? Well, 7 to the half is finished. It's in rational index form. Have a close look at the 4 over the 2 there. That can be simplified as 2 over 1. Or why not just write squared? So 7 to the half times w squared. And that's as far as we can go because the bases are different there. So that relates to our other index laws you should be familiar with. Okay, one last example of these. So it's right there. We have, now be careful, that's a big 3. So 3 times the 5th root of a to the power 7. So the 3 has no powers operating on it. So it stays as 3. And it is an implied multiplication. Now, using that second rule, we have base a, and we have 5 on the bottom. It's the 5th root, and we have a to the power 7. So that would be 3a to the 7/5. And that's written with a rational index. What if we had to write these as surds? What if we have to write 7 to the 2/3? Okay, we use a second law, and we've got a base of 7, and the 2 goes in under the radical sign, and it's the 3rd root. So we have a small 3. So that's the square root of 7 squared. The cube root of 7 squared. Now you could, with these ones, you could go a step further because 7 squared is 49, so it's the cube root of 49. You could write it like that. Okay, another way of doing that, which is probably not quite as good, is you can actually do it this way. You can go, it's the cube root of 7. You can swap the order around, all squared, and that way basically you got an answer. And in fact you can't go any further than that, well, not easily anyway. So you can see that this, while that's correct, that is slightly better to do it that way. So be on the lookout for those. You can apply these two in whichever order you like. Okay, it's important to note that, so the order can swap. Just be aware that sometimes one way will give an even simpler, more straightforward result. So the order at which you do those operations, you can swap those and it's still okay. Final example, what if we have something like, we have to write this as a surd, 27 to the negative 1/3, so we have a mixture of negative and rational index. So you could write that as 1 over 27 to the 1/3. So I'm applying the negative index rule first, and then that's 1 over 27 to the power 1 taken at the cube root, or just cube root of 27. Now 3 by 3 by 3 is 27, so that's 1/3. So always be on the lookout that you can go beyond the surd notation to a simplified number. Sometimes you'll see that. So they're rational indices.